In this video, we're going to look at velocity as a vector. The resultant velocity of any two velocities is their sum. In all calculations involving resultant velocities, it is necessary to draw an accurate triangle showing the velocities so there is a clear recognition of the resultant and its relationship to the other two velocities. For velocity questions involving airplanes, when the velocity of the airplane is mentioned, it's understood referring to its airspeed, so the speed relative to the air it's flying in. When the velocity of the wind is mentioned, we're referring to its velocity relative to the ground, and the resultant velocity of the airplane is the velocity of the airplane relative to the ground. So we can come up with this equation right here. Velocity air plus W is equal to velocity of the ground. Velocity rather relative to the ground. Not velocity of the ground. Okay, draw the following diagrams. A wind blowing from the north. So if a wind is blowing from the north, it's coming from the north and it's headed south. So there's our wind velocity right there. A wind blowing from south 30 degrees east. Well, that means that it's coming in from south 30 degrees east. And if it's coming in from south 30 degrees east, then the exact same vector is going to be here. I'll copy that vector. That exact same vector can be replaced right here, and we can have this is 30 degrees because I knew this was 30 degrees. And so I can say north 30 degrees west. Okay. A wind speed of 55 kilometers per hour north 30 degrees west. Well, that's literally the same direction that we just did. So here we go. I'll make it a little longer because it's 55 kilometers per hour. And that's about 30 degrees right there. And a west wind means a wind blowing from the west. So if it's blowing from the west, then that means it's going to the east. Okay, so that kind of deals with the terminology of wind velocities. An airplane headed northwest at 500 kilometers per hour encounters a wind of 100 kilometers per hour, and we'll put right here, this is blowing from. So let's say right here, blowing from 25 degrees east of north. Draw the resultant ground velocity of the plane. Okay, so 25 degrees east of north would mean that this is my wind velocity right here. So 25 degrees east of north, that's literally the same thing as saying 25 degrees west of south. And so this right here, that's my wind velocity. Okay, and I know that that right there has a magnitude of 100. Okay, and this is 25 degrees. This right here is my airspeed. That's 500 kilometers per hour. And if it's northwest, then that means that this is 45 degrees right there. We see that the airplane is headed northwest, so it's going 45 degrees there. And if this is 45 degrees, well, then this one is 45 degrees. And all of this right here is 70 degrees. So what I need to do is I need to find my resultant velocity. And so that's my ground velocity, or the velocity of the airplane relative to the ground. Okay, so how do I find that? Well, I've got side, angle, side, which means I have to use my cosine law. So I'm going to go ahead and I'm going to use my cosine law. So ground velocity squared is equal to 500 squared plus 100 squared minus 100 times 500, and then cos of the angle in between them. Okay, so that is going to give me my ground velocity of the plane, and my ground velocity of the plane is going to be 475.2 kilometers per hour. Well, at least it's going to give me the magnitude of the ground velocity. There we go, 475.2 kilometers per hour. Okay, I can even write that in if I want, 475.2. All right, and now what I'm going to do is I'm going to find this angle right here, and I'll do it in light blue. This angle between this side right here and this side right here. So this, I'm going to call this angle right here, I'm going to call that theta. In order to find theta, I'm going to use my sine law. So I'm going to say sine theta all over 500 is equal to sine 70 Sine theta over 500, sine 70 over 475.2. Okay, so when I isolate and I solve for theta, I'm going to get either 81.2 degrees or 98.8 degrees. Because remember that if theta is positive and we're using sine, that means it could be either an acute or an obtuse angle. And we have to look at our diagram. So what does this theta most look like? Well, I can see right here from the diagram, this is an obtuse angle. It is not acute. So I can discard this answer. All right, so I know that this angle right here is 98, so that means I can find this angle over here, which I'm just going to call alpha. So alpha is equal to 180 degrees minus 98.8 degrees, so this angle right here, minus the last angle in the triangle, which is 70 degrees. So then alpha is equal to 11.2 degrees, and so I can find this whole angle right here by taking 45 and adding it to 11.2, and that will give me my final direction of the ground velocity. So ground velocity is equal to 475.2 kilometers per hour, and then I'm going to say north 56.2 degrees west. And again, that 56.2 comes from adding 45 degrees plus this alpha right here, which was 11.2 degrees. A pilot points their plane towards the east. The wind blows directly south at 125 kilometers per hour. If the airspeed of the plane is 400 kilometers per hour, determine the velocity, course, and speed of the plane relative to the ground. Well, this one actually is not that bad at all, okay? I'm just going to take these compass coordinates and I'm going to steal them for this example right here. So if a pilot points their plane towards the east and the airspeed of that plane is 400, I'm going to go right here and I'm going to say that that right there is 400, okay? That's 400 kilometers per hour. The wind blows directly south. So if it's blowing directly south, that means, okay, I get another set of compass coordinates here. There's my compass axis, okay? And then I'm going to go directly south at 125 kilometers per hour. So 125 kilometers per hour, we'll say like maybe say that right there. That's roughly about yeah, maybe even a little bit less. There we go. Okay. All right, so that right there is 125 kilometers per hour. And if the airspeed of the plane is 400, well, we already got that. Determine the velocity, course, and speed of the plane relative to the ground. Okay, so this one is fairly straightforward. The reason why it's fairly straightforward is it's making a right angle triangle. Okay, so there's my resultant velocity. There we go. Okay. So this literally is just Pythagorean theorem, okay? So I'm just going to say that the magnitude of the ground velocity is just equal to the square root of 400 squared plus 125 squared, all square rooted, and that is equal to approximately 419 kilometers per hour. Okay, so what I want to do is I actually want to find this angle right here, okay? And I can just use, since we have a 90-degree triangle right here, I can just use trigonometry and I can say tan theta is equal to 125 all over 400. So theta is equal to 17.4 approximately degrees. Okay. And then I can say, therefore, my ground velocity is equal to 419 kilometers per hour. And I can say east 17.4 degrees south. So pointing east, but then 17.4 degrees south. Alternatively, I could say 419 kilometers per hour, and I could say south 72.6 degrees east. Okay, which is actually just this angle right here. Okay, that's 72.6. This was 17.4. Okay, that was a pretty straightforward one. Let's move on to the next. In the same scenario above, the wind now shifts to blow at the same speed, but towards the southwest. What is the velocity relative to the ground now? Okay, so I'm just going to copy what we had above to this example. Okay, so as you can see, I've got my airplane pointed towards the east. That right there is 400, okay? And then I've got the wind now blowing towards the southwest. So if it's blowing towards the southwest, that means it's making a 45-degree angle right here. So I'm going to try and make a 45-degree angle. And remember that this is going to be about 125, so I don't want to make it too big right there. Okay, so here you go. This is 125. And now I'm going to add a final arrow that goes from here. Oops, I want to add an arrow, not move an arrow. Okay, so here you go, final arrow right there. That's my resultant, and that's my ground velocity. And so I'm expected to find that right there. Well, a few things that I know. I know that this is 45 degrees. And if this is 45 degrees and I've got side, angle, side, then I can easily use cosine law to find my ground velocity. Okay, so there we go. All squared is equal to 400 squared plus 125 squared minus 2, 400, 125 cos 45 degrees. Ground velocity then is approximately 323.9 kilometers per hour. Okay, so I've got its magnitude. So now that I have its magnitude, I can even write that in, so that's 323.9. I can determine its direction using sine law. So sine theta all over, and when I say theta, I mean this theta right here. So sine theta over 125 is equal to sine 45 all over 323.9. So theta is equal to approximately 15.8 degrees or 164.2 degrees. Again, recalling that if your theta is positive, that could mean it's acute or obtuse. I look at the diagram, and in this diagram, this 15.8 makes more sense than this one, so I'm going to discard this right here. And now I have my ground velocity. So therefore, the ground velocity is equal to 323.9 kilometers per hour. And I'll write east, and I'm going down 15.8 degrees south. Okay, alternatively, you could say the exact same thing, same magnitude, and we would say south 74.2 degrees east. Either of those work. All right, we are on to our final example. A pilot wants to fly to an airport that is 300 kilometers north, 65 degrees east from their starting position. The airspeed of the plane is 200 kilometers per hour, and the wind is blowing at 80 kilometers per hour north, 10 degrees west. What direction should the pilot aim, and how long will it take to get to the airport? Okay, so we're going to do a couple of things here. I'm going to start with some compass axes. Okay, so if the pilot wants to fly to an airport that is 300 kilometers north, 65 degrees east from their starting position, that is in fact going to be their resultant vector right here. So this is where they need to fly. Okay. I'm going to make this one right here, and it's got to be about 65 degrees. I think that looks 65 degrees-ish, maybe a little bit more. We'll say, yeah, okay. How about like that? Great. Okay, and I'm going to make that my resultant vector. Okay, so this right here is, okay, and this angle is 65 degrees east of north. So this is like their end position. This is where they want to get to, this position right there. That's where the airport is. Okay. The airspeed of the plane is 200 kilometers per hour and the wind is blowing at 80 kilometers per hour north 10 degrees west. So north 10 degrees west. So I'm actually going to draw that in onto this original axis here. North 10 degrees west, and it's 80 kilometers per hour. So I'll put it like here. North 10 degrees west. Okay, so that's my wind velocity. And so what I'm going to do is I'm going to now take that wind velocity. I'm going to take these compass axis, take this compass axis, okay? And I'm going to put this over here. One second. I'm going to put this over here because I know that the plane is going to have to aim in this direction, get pushed up by the wind, and end up over here, right? This is where the airport is, right here. So let's label this right here. This right here is the airspeed of the plane. This is the wind's velocity. I know that this is 10 degrees. Right there, okay? And then if this is 65 degrees over here, and this is 10 degrees, let me just bring this back over here. This right here is 10 degrees. Then this whole angle here is 75 degrees, and I can use my Z pattern to say, oh, well, this one right here's got to be 75 degrees. So again, 10 plus 65 is 75, and I can use my Z pattern, and this is 75 degrees over here. Okay, so what I have here, and I know that my air velocity right here is 200 kilometers per hour, and I know that my wind velocity is 80 kilometers per hour. So what I notice right here is that it is not side angle side, it is in fact side side angle. So I'm going to have to use sine law. All right, so I'm going to look for theta right here. So sine theta over 80 is equal to sine 75 all over 200. Theta is equal to 22.7 or 157.3 degrees. So theta, remember, could have two possible values. I look at the diagram right here, it can only be 22.7 degrees. So I'll have to take a look and let's figure out what the direction the pilot should aim is. Well, if this right here is 22.7, okay, so I'll say, therefore, the direction from the north is going to be 65 degrees plus 22.7 degrees, which will equal to 87.7 degrees. So, therefore, the pilot should aim north 87.7 degrees east. Finally, what I'm going to do is I'm going to find this angle right here. I'll call this angle alpha. Okay? So angle alpha would be equal to, if I know that this is 75 and this is 22.7, angle alpha is going to be 180 degrees minus 75 degrees minus 22.7 degrees. Angle alpha is 82.3 degrees. So if I know that this angle alpha is 82.3 degrees and I have right here I can use my sine law to say, okay, well, therefore, the magnitude of the ground velocity over sine of 82.3 is equal to 200 right here over the sine of 75. It's just solving a whole bunch of triangles right here. And so therefore my ground velocity is going to be equal to 205.2 kilometers per hour. Okay, well, I know that speed is equal to distance over time, and they're looking for how long it's going to take. So therefore, time is equal to distance over speed. So the time is 300. The airport's 300 kilometers away. The ground velocity of the plane is 205.2 kilometers per hour. So that means time is equal to 1.46 hours, or 1 hour and 0.46 times, so 0.46 hours times 60 minutes per hour. So that's 1 hour and 28 minutes. Okay, so yeah, there we go. So I think what we did is we just started off right here. We know that the airport is 300 kilometers away, and we know its direction. So we know that the ground velocity has to go along this trajectory, right? At 65 degrees north of east. So I placed that right there. I don't know what this is. It's not 300 kilometers per hour. I don't know what it is. I can figure this out later. Then I know that the wind velocity was 80 kilometers and it was 10 degrees north, north 10 degrees west, okay, or 10 degrees west of north. And then I was able to take this vector right here, move it over here, and then put in an airspeed vector, and then create my triangle and solve using sine law. Okay, and then I was able to get my direction and then also the magnitude of this side right here. Okay, so that's the lesson. Hope you liked it, and I'll see you in the next one.